Okay, isosceles base angles theorem. Hopefully you've heard the word isosceles before. It has to do with a triangle. Obviously our title, isosceles triangle. So raise a hand, who can tell me a characteristic of, you don't even know the question, you already know the answer, huh? The characteristic of isosceles triangles. Gerardo? How many? Two, at least, correct? Okay, here's a question for you. Well, let's draw a triangle so everyone remembers what that looks like first. Draw it off to the side. If this is triangle ABC, it'd be like AB and BC are congruent. That's the marking of isosceles triangle. So here's the question. Are all isosceles triangles equilateral triangles? Okay, well let's prove it. By raising a hand, who can tell me what an equilateral triangle is? Alex? All three have to be congruent, right? So here's another question. Are all equilateral triangles isosceles triangles?
No. Yeah.
Yes. Just like a square can be a rectangle, but are all rectangles squares? No, so that one goes one way. Same with equilaterals have two congruent sides, correct? So therefore it is also isosceles. Interesting. Okay, so isosceles base angles theorem starts with our knowledge of the two sides. If two sides of a triangle are congruent, if two sides of a triangle are congruent, the angles opposite of them, which we call the base angles, so we'll put in parentheses base angles. The angles opposite of them, called the base angles, are also congruent. If two sides of a triangle are congruent, then the angles opposite of them are also congruent. Do you need to go get some water, Luce? Okay, hurry back. So, side AB, if I'm looking at side AB, what angle is opposite of AB? Angle. So I just need one letter. C. So AB, the only letter I didn't say was C. So this angle is opposite. Okay, BC, what angle is opposite of BC? A. So that would mean these are the base angles. These two angles, angle A and angle C, are congruent. Base angles theorem of isosceles triangles. If two sides of the triangle are congruent, we know the base angles opposite of them are also congruent. Okay? Well, now we're going to say the reverse of it, called converse. So if you remember, not everything goes both ways. For instance, we said all squares are what? No, our squares are also rectangles. Yep. All squares are rectangles. Can we go reverse? Can we say all rectangles are squares? No. So notice this arrow, it only goes one direction. We also said all equilateral triangles are also what type of triangles? Isosceles. Because equilateral triangles have at least two sides congruent. But the arrow only goes one way, it doesn't come back. You can't go reverse and say all rectangles are squares. It doesn't work that way. Some rectangles are squares, but not all. Some isosceles triangles are equilateral, but not all. This theorem we've written above has a converse. The converse means it can go backwards in opposite direction. So write down the word converse. Okay, the last theorem started with the sides and it told us information about the angles. So we're going to go in reverse order. If we know information about the angles, it tells us something about the sides. We're going to go reverse order. So the converse is if, I lost my paper. Here it is. If two base angles of a triangle are congruent, if two base angles of a triangle are congruent, then what can we say? If two base angles of a triangle are congruent, then what? Two opposite sides are congruent, correct. So let's see. Then the sides opposite of them are congruent. Then the sides opposite of them are congruent. And I'm going to add to it as well, therefore the triangle is isosceles. The symbol for therefore is 3 dots in a triangle. Therefore, the triangle is an isosceles triangle. Yeah? So converse means the theorem can go in the reverse order. Not all theorems can, though. What? Parker, do you have a question? Okay, you're just raising your hand, kind of. All right, one more theorem, and then we're done. I hope we're done. Last one. When the altitude is drawn in an isosceles triangle, when the altitude is drawn in an isosceles triangle, when the altitude is drawn in an isosceles triangle, two congruent right triangles are formed. Oops, missed the yellow one too. Two congruent right triangles are formed. And we can prove this by one of our, oh, that was supposed to be a line. Try that again. One of our congruency postulates. And it's the one that I've kept mentioning, but we haven't ever used yet. You remember this yellow foldable that we did? This one only had 4. It had side, 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 angle, side, angle, side, angle, and angle, angle, side. And I kept saying, there's a 5th one. Just be aware, there's a 5th one. We haven't actually used it until now. And on your test, I said, if you see this one, don't select it because it's not the right one because we haven't learned it. HL. Yeah, HL. What does HL stand for on triangles? What starts with an H on triangles? Right triangles specifically. What? Hypotenuse. Oh, really close. Hypotenuse, leg. Hypotenuse, leg. So, let's draw a picture of what this theorem is talking about. Okay, so we need an isosceles triangle.
So it's formed by HL, or?
When an altitude is dropped. We're going to do that right now. So this is A, B, C. To know it's isosceles, we should put congruent marks. Okay. Casey, could you explain, please, what an altitude of this triangle would look like?
would be a bisector angle B
Ooh.
that will cross into line segment AC at a 90-degree angle.
Oh, wow. Excellent. Did you hear the vocabulary word he said? What was the B vocabulary word he said? Ah, yeah. He said it bisects angle B, and then he says it intersects AC at what degree measurement? 90, and actually also bisects AC. Since it's isosceles, this is a unique one, it will end up bisecting. So altitude you can think of as measuring the height. Good job, Casey. That was excellent. Put in a 90-degree angle, and then it's also bisecting AC. So if this creates point D, D is actually going to be a midpoint, which means if I do a double tick mark and a double tick mark, that's showing that it cuts it, and we now have two congruent sides. And technically here we can even prove congruent triangles by side, side, side. Let's practice the new one. Is it true, because you guys see that there's two triangles now, right, inside the big one? Okay, here's a tick mark and here's a tick mark. Those are across from the 90-degree angle. Who can tell me what the side across from the 90-degree angle is called on a triangle? Hyperbole is in English class. But you're close. Hypotenuse. Those are the hypotenuses. Hypotenuse, I don't know. Maybe that is the plural form. And notice they both share this altitude, which means that side is congruent to itself. They both have the same side. It's the reflexive property where a side is congruent to itself. Anything is congruent to itself. So our last theorem, hypotenuse leg, actually that's a postulate. Congruency postulate is if they have a hypotenuse and a leg in common, they are congruent. Who am I looking for? The top one is yes, the bottom one is no. Okay? So therefore these two triangles are congruent. And make sure you realize, because this will help you with the short assignment that goes with this, that we get right here two congruent pieces on the bottom of the base. Okay? So we're just going to practice one quick example using those. And this is actually one straight off of your homework. So I'm not going to tell you what number it is. You'll just have to figure it out. Once you see it, you'll be like, oh, this one looks familiar. Maybe I should look at my notes because I've already done it. Okay. We have markings for isosceles. And the left-hand side is 10. The right-hand side is x plus 1. And I asked you to solve for x. Okay, Carlos Menem, because of these markings right here, what does that tell you other than it's an isosceles triangle? What is congruent? The sides. So what does that tell you about 10 and x plus 1? The sides are congruent. What does that tell you about 10 and x plus 1? Because 10 and x plus 1 are congruent, which means we could set them equal. That's what I'm looking for. They're equal. Congruent means their measurements are equal. And Tristan's already told us this answer. What do we get here, though? No? 9. X equals 9. So on your assignment, there's 10 problems. Yep. Okay, you'll either be... The front side is pretty simple like this. Listen, please. Face this way, please, and listen. The front side, you're either solving for the side, which you can use congruent sides to solve, or solving for x, which is in the angle, you can use congruent base angles. The back side, just a word of warning, we'll probably do one together in the back side to give you an idea of how to do it. You have to use all of your knowledge of all triangles we've done so far in order to solve the back sides. Okay, so I'll pass out the worksheet that we're going to do right now.